Hi, everybody. I'm Thomas Howard. I'm one of the ICE technical marketing engineers, and I'm excited to share with you our latest release, ICE 3.2, which just went into beta last week. And we have a bunch of great features to share with you today. In fact, I can't just share them all with you today. We have to split it up over two different webinars. And so next Tuesday, as Rico said, we have Pavan coming back to share with us a whole another hour's worth of features. And you can see where we have the little mouse cursor. Those are going to be the demos that we show you all. So I'm going to be doing about 6 demos today. We have a lot of great things to cover. So I want to go ahead and jump into that right now. But just to kind of set the theme, the idea here is we want to be able to help you guys deploy ICE more flexibly, give you some more compliance options, provide open data access, and improve the way that you can get data out of ICE, and improve how you can actually view data within ICE using some of the analytics and new reporting capabilities. I'm not going to show you all of these things today because, like I said, we got it split up between myself and Pavan over 2 different webinars, but hopefully you're going to like what you see today. So the first thing is, as you know, since ICE 3.1, we've really been pushing into to do native cloud support, starting with AWS in 3.1. And as of ICE 3.2, we are going to be supporting Microsoft Azure and Oracle's cloud infrastructure. So more choices for you there. And if you want to try it out in Oracle, I'm not going to show you a demo of this today, but we have a fantastic video and document on how to do this in our ICE 3.2 open beta, which I'm going to tell you how to join at the end of this. But just know that it's out there if that's something that interests you. What I am going to do today, however, is I want to show you how to provision ICE in Microsoft Azure. Since I know we have a lot of people interested in that, let's go ahead and do it. So the way this works is you start off by creating a resource group in Active Directory. And I'm doing this assuming that you may be a newbie to Microsoft Azure cloud infrastructure. So you create a resource group. This is basically where all of your different things that you create go. You assign it to a region, and then you go ahead and you can create it. Once you have that done, you need to create a storage account. And by the way, this is how it's done in our beta. This is not going to be how it's done when it actually is released, but this is how it happens right now. You go ahead and you can create this resource group with a storage account, give it a name, and again, pick your region. So once this is released, it will be done in the Azure Marketplace. But right now, as part of the beta process, we're provisioning these images via a virtual hard disk. So we're going to go ahead and create an account with a container. And what we're going to do is we're going to copy a virtual hard disk that our engineering team has made available as part of this beta. Okay, so now that we've got our container created, what we can do is we're going to go ahead and we are going to make sure that there we go, create our container. Got our storage account created. Now we're going to do our container. And we'll be able to copy in we don't have any advanced features, so we don't have to worry about that. But what we're going to do is we are going to copy this image into this container so that we can make an image out of it and then a virtual machine. So now we're going to create an access token. This basically allows us to change the permissions so that we can copy from another container that our engineering team has made available with that ICE 3.2 beta image. We want to change the protocol so we can copy over HTTP or HTTPS. And we're just going to change the expiration. This basically determines the time that these permissions are valid for. And we just generated a blob SAS URL. This basically is a fancy URL that contains a token that we are able to share with others and use. So what we're going to do now is we're going to launch into the Cloud Shell. We're going to run Microsoft. First, we're going to put in an environment variable. This allows us to speed up our copying. And then we're going to run this Azure copy command. And what I'm doing here first, this is the syntax. Just notice it's az copy, source, target, and recursive equals true. We're going to replace that target with that blob sash URL for our container, because that's the target container that we're going to copy the image into. And then in our ISE open beta documentation, we have a URL where you can copy from our container, our engineer's container for ISE 3.2, and copy it to yours. So we're going to do that, and through the magic of video editing and light speed travel, we're going to just jump ahead into the future really fast. Normally this takes about 10 minutes, but we're going to do it in about 10 seconds. And now that that's been completed, we're done doing the AZ copy. And now we can go create our image from that virtual hard disk that we just copied from the ISE engineering team. So we're going to create that image. Again, I'm going to specify what resource group it goes into and give it a name. If you haven't done any cloud platform provisioning, this is basically how it works. You end up saying the same things over and over again in the same region, give it a name, allocate it. We're going to be using ISE. It's obviously on a Linux OS. VM generation 1 is fine. And then we're going to do the container that we just copied our virtual hard disk into. A standard SSD is fine. And let's review it. Okay, it looks good, so we can create it. And again, we're going to speed this up. There's our image. Fantastic. All right, so now that we've made an image from that virtual hard disk, we can go in and make a virtual machine. So we'll create a VM. Actually, before we do that, we need to create a virtual network. So again, I'm assuming you've never used Azure Cloud before. So you have to create a virtual network. This basically has all your like a little pod in the cloud that you put all of your resources into. That has networking and other capabilities built into it. We're just going to call ours our ISE virtual network. And that's great. And typically what this does is you'll notice the IP address space is a 10.0/16 network. You can totally customize that, but my goal here isn't to show you how to do every last feature in Azure Cloud. My goal is to show you how to get ISE up and running quickly. So I'm skipping over those details, but you can totally customize it to a specific subnet on a 10.0 network or any other RFC 1918 network. So now that we've got our virtual network created, we can go back to our image, and now we can create that virtual machine. So again, give it a name. Everything needs a name and a region. All right, so there's our image. You could potentially choose other images, but we're going to use the one that we just created. And this is the standard recommended instance size that we recommend for Azure. There are others. The username, so notice that Microsoft wants to use Azure AD. You can't use admin, unfortunately. So that's a bit of a change. We'll show you that later. So you're going to need an SSH key pair. You can either provide your own or have it create it for you and then download it. I'm opening up the inbound ports. I'm not going to do any kind of ACLs or security groups. And again, the goal is to show you how to make it work, not to show you best practices in security for cloud resources. So notice that it auto-populated the subnet and the public IP for the virtual network under the networking. I'm going to disable the security group. That's not a best security practice. But again, there's a 1,000 different ways to configure security for these things, especially when it comes to the different security groups. You can do it by IP, by port. There's lots of different ways. My goal isn't to show you that right here. It's just to show you how to get this image provisioned to go play with it. You can always go back and change your security group on the virtual machine as well. So uh, here is where it gets interesting. We're going to put in some user data. So we've also supplied some options for you. This is very much like the zero touch provisioning that we showed you in one of our previous webinars by Charlie Morton. We have all these different options that we're able to send in to the ISE virtual machine. And this is exactly the kind of information that you would provide through the CLI if you had an ISE appliance. But we're just going to provide it through a nice little text file to automate that process so we don't have to do it on the CLI. So before we create our virtual machine, you really need to download that private key. Don't lose it, save it, put it somewhere special. And then once you've done that, then it's going to go ahead and deploy. Once that's done, we can go check out our virtual machine. And there it is. So what you'll notice is that we have an IP address assigned to it. So we can go ahead and copy that. And now what we can do is let's go try to SSH into it. Now, obviously, anybody that's booted an Icebox knows it takes a while. And so the first thing you'll notice here is I was able to add it to my local key store, but it was denied. And the reason is because I wasn't using that SSH key. So I need to specify my SSH key that I just downloaded. Okay, SSH one more time. Let's go ahead and change our permissions, right? So I'm trying to show you guys all these things that you're probably going to do as well, so that you don't forget them and that you know how to fix it. So you change those permissions on that file, and now if we use that private key, we can go ahead and log in. So we can go ahead and do show application status ICE. We can see our application server is not yet running because, again, this usually takes a good 20 to 30 minutes for ICE to boot and get the application server running. We may try this again, and you can sit here and you can do this however much you want. What I like to do is, rather than sit here at the CLI and wait, I'll go ahead, because I know it's going to take a while, right? I'll go ahead and just launch a browser and have that connect. So you can see that's our IP address that we're connecting to. We're going to try it. Eventually, the application server will start, but it's going to take a little bit more time. So you're going to get this message on the screen. But if you just sit here and you wait, it'll refresh and refresh and refresh until eventually we should see the login screen. There it is. So now we can log into our Icebox like we normally would. And notice I'm using the admin username, which is wrong because, again, this is Azure Active Directory. You can't use admin. You have to use ICE admin. So you're probably going to forget that like I did. It's a little something to get used to. Okay. So then the other thing that's interesting, besides the telemetry, let's go ahead and get past this. Notice that it's asking us to change our password. This is a new feature beginning in ISE 3.2 as part of the zero-touch provisioning process. So after you do that initial password that everybody just saw me put in through the zero-touch provisioning, I added a new secure password. So you guys don't know what my actual password is on this Icebox. That's publicly accessible on the internet. So with that done, just remind everybody, every ICE installation, you get a free 90-day evaluation with 100 licenses. So go ahead and try that out. And there it is. We now have ISE 3.2.0.366 installed in Microsoft Azure Cloud. All right. So that's the whole process of installing it as part of our beta. If you guys are interested, I'll give you details at the end on how to join the ICE beta, and you can do all this yourself. So zero-touch provisioning, you guys actually saw the first login password change. That's something we started doing in ISE 3.2, so that's a little bit of a different thing now. But you also have the ability to do public key authentication and specify a private key instead of a password. So these are some things that we're adding to help you guys with zero-touch provisioning going forward. So another big thing that people have been asking for with Microsoft's Azure is the ability to do certificate-based authentication and authorization with Azure Active Directory. And we're delivering that now for you in ISE 3.2. So we have the choice of using either EAP-TLS or TEAP, the tunneled EAP protocol, which is available in Microsoft's native Windows supplicant. So you can use these protocols to send a certificate to ISE. But before we get into that, I want to kind of go back in time a little bit to ISE 3.0. And what we want to do is talk about how ISE is able to communicate with Azure Active Directory using username passwords. And then we'll talk about how that's a little bit different with digital certificates. So when we do authentication for username passwords with Azure Active Directory, we are using something called OAuth-ROPC, Resource Owner Protocol, something. I always forget that last little bit. But here's how it works on the internet. If you want to authenticate to an internet resource, if you're doing single sign-on, typically you're using one of two protocols, SAML or OAuth. These protocols are effectively identical in concept. The difference really is that when you use them, you're using XML for SAML or JSON for OAuth. But the way they work is conceptually the same. Here's how it works. You are a resource owner. You want to access a resource on the internet. You have a client, also known as your web browser. You connect to the site that you want to log into. It's going to prompt you for doing some kind of single sign-on. It redirects you to your identity provider, whoever that happens to be. And you prove yourself that you are who you say you are. You might do some multi-factor authentication. At the end of the day, you get a token to get redirected back to that original server site that you wanted to log into. It's able to take your token and validate that against your identity providers to know that, yep, you really are who you say you are, and you're entitled to those resources on this site. That's how it works on the open internet today and has for a long time now, probably almost 20 years with SAML. There's only one problem. When we're talking about getting network access, 802.1x blocks that because you don't even have an IP address until you're authenticated, right? And so this whole process breaks down when you start to use an internet identity provider like Azure Active Directory with SAML or OAuth. If you don't have an IP address, you can't do this three-legged handshake authentication with the authorization server and the identity provider. So what we have to do instead with ISE, and again, this is starting in ISE 3.0, we use 802.1x when you talk to your access point wireless controller or switch. And then you have to do EAP-TLS with PAP as the inner method. PAP is a method that does not encrypt your password. Some people have a problem with this, but we'll talk about why that's okay. We're sending your username and password unencrypted in an EAP-TLS tunnel over to ISE. ISE is then going to proxy your unencrypted username and password over to Azure Active Directory to do the authentication. Then, if that authenticates properly, ISE can then do a check on what groups you are a member of and apply that to our authorization rules and get you authorized to the network based on your group membership. So I said that the security with PAP isn't necessarily a problem. Some people question this or refute it because there are documents that Microsoft has saying that you should never use OAuth-ROPC. And that is true if you are talking to some random site on the open internet because you don't know that site at all. When we're talking about ISE doing OAuth-ROPC for network access, this is our managed corporate device with a provisioned supplicant with certificates talking to our ISE network access control server to authenticate our users and determine if they are allowed to access our corporate network or not. That is a very different kind of security scenario compared to random single sign-on on the open internet with OAuth-RPC. So I agree that if you're going to do that with some random site on the internet, that's a bad idea. But in this case, it's okay to do that. And there really aren't any other alternatives. If you want to be able to use Azure Active Directory or any other identity provider with SAML or OAuth, your options are pretty limited. And I would love to know how else you think that could be done. So That's why we do it this way, and we think it's secure. It should be fine. So that's how we did it in ICE 3.0. But that's not what we're here to talk about. We're here to talk about ICE 3.2 and doing it with a certificate. So here's how this works. You have a certificate on your client, and it has a subject common name that needs to match the full, they call it the UPN in Azure Active Directory, but it needs to match exactly your username in Microsoft's Azure Active Directory. We send it over using EAP-TLS or TEAP into ICE. ICE can then apply a certificate authentication profile to make sure it matches against known certificate authorities in ICE. And then we can take that authenticated subject common name and compare it to a group lookup inside of Azure Active Directory for authorization. So notice that we aren't doing authentication to Azure Active Directory here. All we're doing is doing a group lookup based on a authenticated certificate with a subject name, right? So some people are wondering, well, can I do MFA, multi-factor authentication with Azure Active Directory in this scenario? And the answer is no, because the authentication is done by ICE with the certificate subject common name. We aren't going to Azure Active Directory for authentication. So you can't do an MFA there with Azure's Active Directory in their authentication process. So just want to be clear on that. So once we have your group information, we can apply an authorization rule and let you into the network. Okay, so that's how that works. And real quick, this is the digital certificate. Notice there's the subject common name. And inside of Azure Active Directory, you can see the UPN or user principal name. These things need to match. And that's how you can do an authentication. So real quick, let me show you what that looks like. So inside of Azure, if we go to our Active Directory, you can see that we have some groups. And so I've created some different groups here in my Trust Zero Active Directory domain. And I'll have some employees. These are the members of the employee group, employee and Thomas. If we look at our generic employee, we can see there's that UPN, right? That's part of our subject common name. Notice that it's down here as well for the user principal name. And then there could be some other attributes that we could potentially match on too, right? So we have different departments we could match on. We have job title. We could do company names. We could do city. We can do country. We can do all kinds of different things based on these attributes stored in Azure Active Directory if we want to do those kinds of group matchings and attribute matchings. So what we can do is, by the way, I also just want to show you guys the app registration that we did. We have a document on how to do this, but when we create an app registration, this basically allows ICE to talk to Azure Active Directory. You need to have an application ID, a directory ID, as well as a secret that only you know for this particular connection. And we have the token with some identity claims. We have API permissions to let you read from Microsoft's Graph API. You have to be able to read those directories that they're a member of. And then we have that secret, which only I know because I've downloaded it. And we want to make sure that it's only used for ICE and nothing else. So inside of ICE, the first thing you do to enable the REST identity store is you go to the settings page and you enable it. It takes about 30 seconds to enable. We have it off by default if you don't need it. But once you enable it, you can go in, and by the way, this is the certificate authentication profile if you've never done that before. It's the standard one. We don't change anything. It works just great this way. There's that subject common name. You could potentially authenticate something else, but again, with Azure Active Directory, we need the subject common name, which matches the UPN. And we're not going to change anything. We're just not going to send it. We're just going to do the authentication locally in ICE. Then for the Trust Zero's Azure Active Directory, we've got our client ID, the secret, the tenant ID, and we can test that connection to make sure it works. We're all good. Then you need the username suffix for your domain in Microsoft Azure. Note that the @ symbol is there. You need that @ symbol. Don't leave it out. Then you can, if the connection is good, you can load your groups. You saw the groups that match what I had. And I have the ability to if I want to do some additional attribute matching for my users, I can choose these different user attributes, and there's a whole bunch of them inside of Azure Active Directory, just like you would have with Active Directory, but now it's in the cloud. Um, these are all the different attributes I could potentially match against in my ISE authorization rule. I check the ones I'm interested in. You can, check or uncheck the ones that you care about. But now that that's done, let's go take a look at our policy. All right, so we have an 802.1x policy for either wired or wireless.1x. Again, I'm doing EAP with TEAP or TLS or TTLS because I'm going to show you both methods for Azure Active Directory. I can do certificate-based authentication using either EAP-TLS or TEAP, and I'm going to authenticate it against that preloaded certificate profile. And then I could also use TTLS, but I would only be talking to Azure Active Directory. So I actually created a identity source sequence with only Azure Active Directory in it. Then for the authorization profile, I've created these different rules for my employees based on the principal name, based on the department they're in, based on the external groups they could be in. So I've got all these different rules I can create using those different attributes and groups that I showed you. So now I want to bring up my EAP test tool. So what I'm going to do is I'm going to talk to my ISE node in Azure Cloud. I am going to use my employee certificate with, I'm sorry, not a certificate, this is TTLS. So I'm going to use username password with PAP. That worked. Let's go take a look at the live log. All right, there it is. You can see I authenticated using my username and password in Active Directory using OAuth-ROPC. I authenticated with eap-ttls, matched that policy for .1x, and I matched as an employee based on my group membership. So that worked great. Now I'm going to go in and I'm going to change this. Instead of using eap-ttls, I'm going to use there it is. We're going to use eap-TLS. All right, so I'm going to send a certificate for employee@trustzero.onmicrosoft.com. And unfortunately, I'm getting an access reject. So I know you guys like to troubleshoot. You want to see how we troubleshoot things around here. So sometimes things fail. But you can see I did match the certificate, but unfortunately it failed through my authorization rules and denied me access. So we're going to take a look at the live log here and see what's going on. So it fell through, hit the last rule and the authorization profile. You can see my username looks good because it's that full UPN. Use the certificate profile. That's all good. Common name is there, just like it's supposed to be. We can see we have some additional attributes in the certificate. We're not using them, but they're there. So what I found is if you look over here, you can see authentication passed. EAP-TLS is working. It looked it up, but unfortunately, and we even looked up, we did a query in the Azure Active Directory, but it still denied access. So something's going on here. We don't know what it is. So now we got to go do some debugging. So go into troubleshooting. Let's go take a look at our configuration. Let's make sure that debug is enabled on our logs. And so if you're doing the REST identity store, you want to go down to the REST ID store for logging. Let's make sure it's in debug mode to get all the possible debug details. And then we can go down, after we do an authentication in debug mode, we'll be able to see those things and download our log. So let's go find that REST ID store log. There it is. And we can click on it and download it. I'm not going to show you the gory details of everything that was in there, but I will show you the relevant parts. It's right here. So when I did this, I got a authorization request denied with a 403. So there's some kind of a permissions problem or authorization problem with Azure Active Directory. Not quite sure what that is. I have a call out to the the engineer to understand why that went wrong. Again, it worked fine with OAuth-ROPC with username password, but I think there may be some other admission that I'm needing for doing certificate-based authentication with their groups. I'm not sure what that is, but I'll have to work with them to figure it out. So anyway, that's where we're at right now with the beta and this feature. At least that's where I'm at. And if you join the beta, I'll keep posting updates to let you know what the resolution is to this when I find out. With that, I want to go on to the next thing, which is reminding you that we're continuing to add API-based things so that you can do all kinds of automation and really cool things with either Python or Go, which are used for Ansible and Terraform. And one of the ways we're doing that is by actually going back and updating our external RESTful services, or ERS REST APIs, and we are letting you, we have a spec that you can now use. So I'm going to show you how to get that. So if you go to the API settings, you can see we've added this link down here for the ERS OpenAPI spec. And if you go ahead and log in, you can see that JSON output. You can save it. And you save it to your computer. You then have the ability to open it in something like Postman. You can import it as an OpenAPI file. There's a whole bunch of different JSON files you can see that are inside of ISE for ISE 3.2. Depending on what API you're interested, you can import these all into Postman and use them. I get this import failed error, but it's actually in there. So I don't know why Postman has a problem, but there are the ISE ERS APIs inside of Postman if you want to go use them. So that's kind of the process on how that works. The next thing with respect to APIs is supporting the patch method. So if you're not familiar, the idea here is before you would have to provide the entire contents of an object or a resource inside of ISE in order to do an update on a single field. That is a lot of work. And so the patch method allows you to have to only send a single attribute that you care about changing, along with the identity of the object inside of ISE. So I want to show you all what that looks like real quick. So hopefully it'll make it a little more clear. But it's not really a GUI thing, it's more of a command line thing. So it looks like this. So what we're going to do is we are going to run a little curl command here. And I'm doing curl because it's kind of the lowest common denominator. It's curl. You can see we're going to say we want to get some JSON back. We're going to authenticate HTTP basic, and we're going to get a network device, or all of our network devices actually. I only have one configured. So you can see we got one network device coming back. It has an ID. So this is our UUID for it. And I have a wireless LAN controller, and there's the description, WLC. So what I can do is if I wanted to go ahead and get the full details of this object, I would just append this UUID to the end, and now you can see how my network device is configured inside of ISE. You get all the gory details, right? There's all the authentication settings and IP addresses and all that fun stuff. So I'm only interested in this example of changing the description. So what I'm going to do is I'm going to paste in another curl command. And what we're going to do this time is, we got to get that ID. Don't forget that. It has to know which resource we're trying to change. So we have to specify that at the end here of the patch command. So in the URL, we include the resource we want to change. So we got curl. Notice that we're telling it we're going to send some JSON this time and accept some JSON back. And instead of WLC as the description, I'm going to change that description. Oops, not there. Back down here. There we go. I'm going to change my network device description. And I'm going to send that. Okay, I got output back. There's my network device, WLC. Same ID, but look at my description. It changed from just WLC to my new description. So I didn't have to send that entire block of JSON into ISE. So hopefully that makes your coding simpler, makes everything just faster and easier. And if you only want to change something like a description, you don't have to do a full query on the network device to get all this gory detail. You only need to just do the initial get on all of your devices. So that's an interesting thing that you can do with the patch command in ISE 3.2. And this works for all of the ERS APIs, by the way, and I believe the other open APIs inside of ISE 3.2 as well. So you can use the patch command on any of those resources. So we also have this other cool feature. A lot of people, a lot of customers are asking for integration with ServiceNow. And the reason for that is because ServiceNow is something that a lot of customers are using to track their device inventory, their endpoint inventory, because there's a lot of devices, whether it's a workstation computer or whether it's a camera or some other piece of gear that they use. They have an inventory database where they track everything, and there's a lot of good stuff in there. So if you take a look at something like ServiceNow, this isn't a sample database, but there's just hundreds of columns of interesting things in here potentially that we could be using in ISE to help with authorization, especially when something does not do 802.1x. So we sort of have a way of doing this today using endpoint custom attributes. The problem though is that you must manually configure these custom attributes in the ISE GUI. You can't do it via API. And then if you have, like I said, 100 columns or more of data that you potentially want to use, you've got to configure each one of those manually, which isn't fun. And then you have the problem is, well, what if I have multiple tables in ServiceNow or some other database that I want to configure? Now I might potentially have like a namespace problem where they both have columns that are named the same thing. That can make things more difficult. So how do I deal with that namespace resolution issue? And if you look at the data here, this is a sample row out of a table like that. And what you can see here, it looks kind of crazy at first if you're not used to reading JavaScript object notation, but there's actually really good stuff in here. Take a look. So first of all, think about a primary key in a database. So we have either the sysID field, which is really more of just a random, unique UUID or something. And then we also have a MAC address, which is really what we think about as a primary key in our network, right, at layer 2. So we could use either one of these potentially as a primary key. It's also good to know when was this object last updated. If we want to update ISE and know when something changed, it's good to know either a version number or a time or something that tells us it changed. And then now we're starting to get things that are interesting. So community group. This is kind of like Azure Active Directory and group membership, right? Now we know that it's part of some community group that we could use for our ISE authorization or policy matching. And it might have some other interesting attributes like status, whether it's operational or decommissioned or maybe it's even been quarantined or something. We don't want to let it on the network if it's not operational. And then you have other interesting security information that we could potentially say, which is what security group should we assign this device to when ISE sees its MAC address, right? That's pretty cool. So here's how that works. What we've done is we have created a way of synchronizing an external database, a JSON-based API database, into ISE as an external server. And so the way you do this is we have a wizard we've created. We're going to create a connector to this database inside of ServiceNow. So we give it a name. So remember I talked about that namespace issue, right? We want to make sure that we have, this one is for our ServiceNow CMDB database. We can check for our certificate. We have a URL. So each table has some unique URL that we use to access it. We need to have authentication that we use. We can test that connection to make sure it's valid, good. There's also an incremental URL for being able to do updates to know when something changed. We want to be able to synchronize this, continue getting updates from this thing. And so for that, we want to have some kind of a synchronization schedule that we set up to say how often we want to check for updates. Maybe it's daily, maybe it's weekly, when we're going to do a full sync of this database. We can do incremental updates, but it's good to do a full sync once in a while to make sure we get all the deletes. Then, as you saw in JSON, there's usually kind of a parent object like result or results, and that's what it looks like. There's our first row of data, so we know we're connecting to it properly. And here are all of the columns in that database that we could potentially be pulling from and using in our ISE policies. So we've selected everything, and we're deselecting the ones we want to keep right? There's the community group, there's the status, the MAC address, the segmentation group. We want to keep those columns or fields, and we want to delete the rest. We don't care about all the other ones. Those are the ones we want to use. So we can include those in our dictionary in ICE. And you notice on the right-hand side, we have names, very nice names. None of those, we can totally customize those if those names don't make sense to us. And now we've just basically have created an ICE dictionary. So then we also want to specify for identifiers, what is that unique primary key for identifying each object? And how do we know when it's been updated? What's the version identifier? Is it a time? Is it a version? How do we do that? Then we have this summary of all the features, or configuration settings, I should say. If that looks good, we can submit it. And now we have our external database that will synchronize. And by the way, references, if you've ever configured something and wondered how you try to delete it and you can't because it's in use somewhere, the references will actually show you where it's in use. That's a pretty cool thing. We'll come back to that. So if you go under dictionaries, scroll down, you'll see that Snow CMDB, ServiceNow CMDB. Take a look at it. There's our dictionary. And there's the attributes that we configured. And we don't have a way yet to view the data that was synchronized and pulled across. And you'll see how that can be a problem in the future. But again, it's a beta, but just bear with us here. Authorization profiles. We have that. We're going to create a Snow authorization. And what we can do, we don't have to do this, but we can use that segmentation group tag. We can use that in our authorization policy, right? That's pretty cool. And now we'll take a look at our policy set that we created. We're actually going to make a new policy set. So this one is going to be MAP. Like I said, a lot of this is used for IoT type devices that don't do .1x. So we need to authorize them based on other attributes. So having this database is really nice. So we're going to do either wired MAC authentication bypass or wireless MAC authentication bypass. Make sure we got that or in there. Good. And then we can make sure that we're only checking our endpoints for a call check, right? The MAB authentication. So it's not there. Let's create a new one real quick. So we're going to do MAB. And we want to disable all the protocols that we don't care about. We only care about process host lookups. Let's uncheck all of those other ones. That's how we do a MAB request inside of ICE. Okay, we got to save that and check MAB. We got to save it again before we drill down and create our authorization rules. All right, now for our authentication policy, we basically want to just check our internal endpoints, right? Again, these are usually IoT devices, so just our internal database. And I should have checked if auth failed continue. I forgot that one, but if we have any problems, just continue. Just keep going down on the list of authorization rules. All right, so the secure default deny access. So now we got to create some rules that these devices may potentially match on. So first one we want to do is if it matches that community group that was in that database. So let's specify the Snow CMDB. There it is. And pick an attribute. Community group is the one we said we wanted to match administration against. And we have the ability to match against any of the other attributes too, depending upon how granular you want to get, right? Remember that status? Maybe you want to make sure that it's operational and in the administration group. So let's use that. And looks good. And we can specify that Snow authorization, where now it's not only going to use it in the conditions for authorization, but it's also going to apply the security group tag from that database as well. So cool. So now what we want to do is let's go check it out and do an authentication. So nothing there yet. So now let's bring up our handy dandy authenticator. We're going to do that MAB authentication with PAP. That's fine. Make sure we have our username and our matching password for MAB, right? And with that, we can go ahead and start the authentication. And unfortunately, this one fails. Um, the reason is because I think inside of this, it's not the data didn't quite sync for me. When I ran this test, it wasn't quite working. I haven't had a chance to go back and troubleshoot it again. But you can see that it failed in the live log. You can see the reason why it did look it up. It did find it. It was okay. So it passed authentication, but when it queried the database, it didn't quite get it. So I think my synchronization failed. And where I said that having the ability to preview that data that we synchronize would be really nice. That's something that's still missing in the beta. So we'll see if that's something that we can fix by the time that this is generally available. But I wanted to show you all that how that works. So the last thing I want to show you is those references. So we did the configuration of the ISE authorization rules, and you can see that is where this CMDB external database is being referenced. If we ever wanted to delete it, we'd have to go and remove those rules. So that's pretty cool that we've included that. If you've ever tried to delete things and not been successful because it's being used somewhere else, now we tell you where it's being used. So there's that. Also wanted to mention that we have APIs for it. So if you want to be able to configure it in an automated way, you have the ability to automate this process of configuration. And the last thing I want to mention is I showed you everything today with ServiceNow because this is what we've been hearing from many of the customers that want something like this. But I know there's a lot of other databases customers use, not just ServiceNow. So if this idea sounds great, but you're not using ServiceNow, I heard the other day, Google Workspaces is another kind of database that has the ability to do JSON table-based queries or exports. Maybe that's one that you would like to see. Do you have other products? So if you could, when this webinar is over, you're going to get prompted for a survey response. Please tell us what additional products we should be pulling this kind of data from. We'd love to go test it, configure it, provide you guys some documentation on how it works. Maybe you want to join the beta and test it yourself. Let us know how it goes over there. So either way, that's great. But I just want to get your feedback and see how you think we can improve this feature inside of ISE. EDDA is our working name. That's not going to be the final name, but that's what we're calling it for right now to get that external data into ISE. So a few other features here that we put into ISE 3.2 is the ability to have a password expiration date inside of ISE and display it there in the GUI. And we've updated the internal user resource for APIs to have this as well. The way this works is if you create a user, give it a password. Oh, before you give it a password, so password lifetime. So basically you can specify an expiration date or say that it never expires and give it a password. And then we have the ability to do account disable policy as well, if that's something you're interested in. Then you can now specify your different columns and they're there. So before, if you had an internal user, you never knew when it was going to be expiring. Now we're actually going to tell you the date that the account was created on and when that password is going to expire, so that you have some warning before you try to log in and it just doesn't work anymore. Or if you're trying to figure out how long was this account created for, when is it going to expire, when are they going to have to do their password rotation, all those kinds of things. It's now there for you in the GUI. Another thing that people are interested in now that, you hear the telcos really pushing the 5G stuff, and they're trying to push private 5G as another means of providing access to large customers over their network, sort of like a private internet connection. So if this is something that interests you, we're now doing 5G based authentication and authorization with ISE. We're now supporting that. So if that's something that interests you, you may want to join the ISE beta. and can learn more about how to do that. I don't have a lot of details for you here. It does require integration with some other Cisco products, but know that that's out there if that's something you're looking to do. And with that, uh, I encourage you to join the ICE 3.2 open beta. If you go to that URL, cs.co/ICE-beta, you can register, and I encourage you to read the form. We get a lot of people that forget to check certain boxes and include their email address, and they don't get authorized and things like that. So make sure you read through everything. Don't just skip over things. And you'll get access to an ICE 3.2 open beta WebEx space that's where we will provide support, Q&A, things like that. This is not a TAC supported beta, so don't think you can install this in production and call TAC right away. It doesn't work that way, and it's all covered in the form when you sign up. But we have started. We started it last week, so we encourage you to join this, and you can get ICE in Azure. You can get ICE in Oracle's cloud, or you can get a traditional ISO to install in your own VM. And our partners and employees can also access it inside of Cisco's demo cloud or D cloud to play with it there as well. So we have lots of different options for you, and it's going to go through about the end of July. So I encourage you to do that. And that is only the first half of the features coming in ICE 3.2. We have a whole nother set of features that I wasn't able to talk about because we don't have enough time. Pavan, our other TME, is going to be talking about it this coming Tuesday at 8 a.m. Pacific time. So I encourage you to sign up for that webinar, and we'll be able to have you learn more about those other features that are still coming.